Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra. This is lesson 7.4 on solving polynomial equations in factored form. Okay, so let's kind of break down that title real quick. Polynomial equations, we know what polynomials are, and we know what equations are. So polynomial equations are equations that have a polynomial in them. And how do we solve that? Factored form, well, that's going to be a little bit different. What's that? Well, we'll talk about that as we go. Factored, we know, means multiplication, right? Factors are those things that we multiply. So let's go ahead and look at some examples here. The first thing we want to talk about, though, is the zero product property. The zero product property. Let's think about what this means here. Zero product means, well, if we multiply two things together and they equal 0, such as A times B equals 0, then what do we know about either A or B? Well, we know that A has to equal 0 or B has to equal 0. One of these two things equals 0. There's no way to come up with a product that equals 0 and not have one of your factors be 0. So we're going to use this idea when it comes to polynomial equations. But before we actually get to polynomial equations, we're going to talk about what they look like in factored form first. By factored, I mean it's multiplication. We know that polynomials are monomials that are added together. Polynomials, what if we rewrite those as a multiplication expression? So here's an example here. Now I know we're calling these polynomial equations and they don't look like polynomials yet, but we're kind of going backwards, or we're kind of doing the last step first here. Okay, so here I have 2x times x minus 4. So I actually have two factors here, right? So I have 2x. I'm going to set that equal to 0. I'm going to take x minus 4 and set that equal to 0. Again, a times b equals 0. So one of these or both of these can equal 0. In the first case, 2 times x equals 0, so x equals 0. X minus 4 equals 0, so x equals 4. That's right. I'm going to have two solutions here. I have two x's, don't I? X minus 3 times x minus 9. This is our this is what we get when we multiply. We're going to multiply together two binomials. We're going to get something that looks like this. What's it going to look like? Well, x minus 3 equals 0, and x minus 9 equals 0. It's already in factored form, so x equals 3 and x equals 9. Okay, pretty straightforward here so far. Let's take a look at these. These are a little bit different in that they're written a little bit different. 2x plus 7 equals 0, and 2x minus 7 equals 0. Okay, so in this case, I have to subtract 7 from both sides. 2x equals negative 7, so x equals negative 7/2. Over here, if I add 7 to both sides, 2x equals 7, so x equals 7/2. So in this case, because these are with the sum and the difference of the same two terms, we're going to get a positive and negative version of the same answer here. X minus 1 squared equals 0. Well, I could do this twice. I can think of it as this, but you'll see I have the same root both times. So if x minus 1 equals 0, x equals 1. And I'd get the same thing if I did it again for this one. So in this case, I only have one solution to this equation because it's a square. This is a square of a binomial. Here I've got three factors multiplied together, but we'll just do the same thing. We set each of these equal to 0 and solve for each of these separately. And in this case, I would have a three solutions. X equals -1, x equals 3, and x equals 2. If I multiply all these together, this would be a third-degree polynomial. I have x cubed as my leading term. So I have three solutions there. Okay. Let's talk about factoring polynomials now. And this is factoring using the greatest common factor. So we have to think about what we mean by the greatest common factor. Well, the greatest common factor is the is the greatest thing we can factor out of both of these things together. So let's talk about the 4 and the 24. Well, just think of those as just regular numbers. So if the greatest common factor of 4 and 24 would be 4. All right. I'm going to write it over there. You'll see what I'm going to show you these parentheses right now. We're going to turn it into a factored expression here. And then x to the fourth and x to the third, the greatest common factor is x to the third, because this is x to the third times 1. This is x to the third times x. So x to the third is a factor of both of them, and that is x to the third. Okay. So now, what do I need to multiply by x? What do I need to multiply times 4x to the third to get 4x to the fourth? Well, that would be an x. Plus, this sign's going to stay the same. And then if I multiply 4x cubed times 6, I'll get 24x cubed. Now, if you do this right, you shouldn't have the same variable in both terms here. So up here, I had x to the fourth, x to the third. I only have x in this term over here now, not over here. Also, when you have an example like x to the fourth, x to the third, where you have the same base and different exponents, the greatest common factor is always going to be the one with the smallest exponent on it. X to the third because my greatest common factor, because again, x to the fourth is just x to the third times x. So the one with the smallest exponent becomes my greatest common factor. Okay, so this is the factored form of this. So how are we going to use that? Well, here we have actually now polynomial equations. And we're going to solve these by factoring. We're going to factor first and then use the zero product property to solve. For 2x squared plus 8x, my greatest common factor is going to be 2x. And what does that leave? Well, again, if I think of dividing 2x squared by 2x, I get left an x. And 8x divided by 2x is 4. Okay, so I have 2x times x plus 4 equals 0. So I have 2x equals 0, and x plus 4 equals 0. Then x will equal 0, or x will equal -4. For the second example, 6n squared equals 15n, I have to set one side equal to 0. Okay, all the examples so far had one side equal to 0, but in order to use the zero product property, I have to clear everything out of one side. So I'm going to subtract 15n from both sides. And that's going to leave me 0 on the right, and then 6n squared minus 15n on the left. Okay, so now my greatest common factor for 6 and 15 is 3. My greatest common factor for n squared and n is n. So that's going to leave 2 minus, 2n, excuse me, 2n minus 5 equals 0. Okay, so now I can use the zero product property and write two equations, one for each factor. N will equal 0. And over here, 2n equals 5. So n equals 5 halves. And those are my two solutions for this equation. Okay, so zero product property, factoring using the greatest common factor. We're going to explore different ways to factor later on. And then setting one side equal to 0, very, very important. That's it for now. I will see you in class next time. Thanks a lot. Have a good rest of your day.